We have been solving proportions recently, and today we're going to put that more in the context of a word problem. So we're going to put what we know about ratios, proportions, unit rates. We're going to put all of that together today to do some problem solving. So look at our first problem. At a special sale, you can buy 3 DVDs for $24. How much would it cost to buy 9 DVDs? So you should take a look at this and see that the two things that are related are the 3 DVDs for $24. You can show that with a bridge map. You can show that as we're comparing the number of, or the cost rather, to the number of DVDs. And it doesn't necessarily matter which one you put on top, but we have talked about when we do comparisons with rates and all, generally you put money on top if there's money, and if not, you put the bigger number on top. So $24, and for $24 we can get 3 DVDs. So remember, this middle section shows the relationship we know. $24 for 3 DVDs. The question is, how much would it cost to buy 9 DVDs? So we're looking for how much would it cost. That's our amount of money. So that's where we're going to put our variable. And we want to use it to buy 9 DVDs. So the 9 has to go on the bottom. And the reason the 9 has to go on the bottom is because it's a number of DVDs. If we look at solving this, this is a pretty easy one to solve. If I look at a ratio of 24 to 3 equals x to 9, I can pretty easily solve this one by saying, well, 3 times 3 is 9. 24 times 3 then is 72. So x is $72. It would cost $72 to buy 9 DVDs. We're actually going to look at each problem today and solve it a variety of ways so that you can choose whichever method works the best for you. You don't have to know how to use all of them as long as you can use at least maybe 2 of them fluently. So another way we could have done this is really to set it up the same way, but I'm going to put one more section. We could look at the cost compared to the number of DVDs, and we know that that's $24 for 3 DVDs, but we can, if we want to, find the unit price. Remember how we find unit price. We're going to divide by 3 to find how much for 1 DVD. And 24 divided by 3 is 8. So that means it's $8 per DVD. Well, then I want to know how much for 9 DVDs. Again, the 9 goes on the bottom because it's a number of DVDs. So I can do 1 times 9 to get 9. And 8 times 9 then is 72, and it would be $72. So that's a way I could do it. I can also do this same problem using what's called a double number line. So let's think about what a double number line would be. Well, it's going to have a number line, and it's actually going to have 2 because it's a double number line. And it's going to show the two things that are being compared, which are the cost and the number of DVDs. So look how these methods are all pretty similar. We're identifying what the things are that are being compared, and then, or that have a relationship, and then we're showing what that relationship is. This time we're going to show that relationship on number lines, 2 number lines. So think about our number lines. We're going to show that they can continue going on and on. This is a relationship that we could go as far as we wanted to with. But what we know is that if we buy 0 DVDs, it costs $0. What we also know is if we buy 3 DVDs, it costs $24. So the 24 needs to be directly across from the 3 to show that relationship. And I actually usually, when I'm doing this, I would draw a line totally between the 2 number lines to show that relationship, to show that they're at the exact same place. So 3 DVDs for $24. So on my number lines, on the bottom one, I'm going to be counting by 3s. So 3 DVDs, 6 DVDs, 9 DVDs, 12 DVDs, and I could go as far as I wanted to. On the top, I'm counting by 24s. So 24, 48, 72, 96, and again, I could keep going on as far as I wanted to. But look at that then. It shows my relationships. For 3 DVDs, it's $24. 6 DVDs cost $48. 9 DVDs cost $72. 12 DVDs cost $96. So the question was how much for 9 DVDs? So it's going to be $72. Interestingly enough, I could also, if I wanted to, find the unit price using this diagram because I could say, well, 3 divided by 3 is 1, and 24 divided by 3 is 8. So I could show one DVD costs $8. And then if I wanted to, I could count by 8s on my top number line, and that would give me how much for every individual CD. So one DVD for how much for each individual DVD rather. One DVD for $8, two DVDs for $16, three for $24, four for 32, 5 for 40, and I could keep going on if I wanted to. I don't have to, but notice that relationship that you can show on the double number line. All right, let's look at another example. You get paid $8 for 2 hours of babysitting. How much for 7 hours? So I could set up a bridge map for this. And I'm going to look at the cost compared to the number of hours. The relationship I have is $8 for 2 hours. And what I want to know is how much money for 7 hours. 7 goes on the bottom because it's a number of hours. Now when I look at this one, notice I can't do 2 times any whole number and get 7. So I might want to use cross products, or I could use cross products to solve this one. So 2x equals 8 times 7, which is 56. When I solve that equation, 56 equals 2x. Divide by 2 on each side of the equation, and I'm going to get x equals $28. This is also one that works really well with unit rates. And so again, comparing cost to hours, $8 for 2 hours would be $4 for 1 hour. Well, if it's $4 per hour, I can then multiply by 7. 1 times 7 is 7, and 4 times 7 is 28. Then it's $28 for 7 hours. Looking at another one, it takes 3 cups of sugar for 4 gallons of tea. How much sugar for 20 gallons? So using the methods we've looked at so far, you can choose any of the 3 we've looked at. A lot of people tend to like the bridge map method, so I'll use that, but then I'm going to show you another one. It takes 3 cups of sugar for 4 gallons of tea. How much sugar for 20 gallons? So the things that are related are 3 cups of sugar for 4 gallons of tea. So the cups of sugar, it really doesn't matter which one you put on top, but we did talk about the fact that normally you put the bigger number on top, so we'll go with that. That's fine. So the number of gallons of tea is 4 to the number of cups of sugar, which is going to be 3. So the ratio there is 4 to 3. 4 gallons of tea requires 3 cups of sugar. And the question part says, how much sugar for 20 gallons? So this time I'm looking for the amount of sugar, so I'm going to put my variable on the bottom because that's where my sugar is, and I'm going to put the 20 on the top because that's where my gallons of tea are. So I have to do 4 times 5 to get 20. 3 times 5 equals x, which means it's going to be 15. So my answer is 15 cups of sugar. Now, another method for solving this problem is to use what's called a tape diagram. Here's what a tape diagram looks like. I still use those same units, and I still set up the same relationship. The gallons of tea is going to be represented by 4, so I'm going to draw 4 boxes. And then my cups of sugar, to represent that, I'm going to draw 3 boxes because my ratio is 4 to 3. Now what I know is I have 20 gallons of tea. So when I look at this, that 20 gallons, if this has to be 20 gallons, then each section has to represent 5 gallons. And I know that because 20 split into 4 parts is 5. So each part has to be 5. Well, if I have 4 parts that are each 5 here, then the cups of sugar has to be 3 parts that are each going to be 5. They have to have the same number in them. So 20 gallons of tea requires 5, 10, 15 cups of sugar. And that's a tape diagram. And that is a great way to show relationships as well. Looking at another one. Justin has 2 Fords for every 6 Chevrolets in his model car collection. If he has 21 Chevrolets, then how many Fords does he have? Take a moment to pause and try this your way, and then we'll look at it. All right, you could have chosen any of the models we've done so far. I probably would solve this one using a tape diagram, or not a tape diagram rather. I would use a bridge map, which is I'm going to use to do equal ratios. So I know Justin's ratio is 2 Fords for every 6 Chevrolets in his model car collection. I'm going to put Fords on the bottom, only because I like to put the bigger number on the top. So 6 Chevys for every 2 Fords. The question part says if he has 21 Chevrolets, then how many Fords? Well, he has 21 Chevrolets, and what I want to know is how many Fords. So X goes on the bottom because it's a number of Fords. And I can pull this off of here and use my cross products and then solve the equation. 2 times 21 is 42. 6 times X is 6X. So 6X equals 42. When I divide by 6 on both sides of the equation, I'm going to get X equals 7. So he would have 7 Fords. So another method that I can use for this is I can use a table to organize my information. So I could say, well, the number of, or the ratio rather, of Fords to Chevy is 2 Fords to 6 Chevys. And then I could say, well, I want to know how many Chevys there are going to be if I have, or I want to know rather how many Fords there are going to be if I have 21 Chevrolets. So notice again, I've got some ratios going here. A ratio of 2 to 6 is equal to a ratio of X to 21. Now there's no easy way to multiply that. I can't go straight from 6 to 21. So I would say, well, a ratio of 2 to 6 is equal to a ratio of 1 to 3. And I know that because 2 divided by 2 is 1, and 6 divided by 2 is 3. And then once I know that, I can say, well, it took me 3 times 7 to get to 21. So do the same thing over here. 1 times 7 is 7. So X has to equal 7. Now, a lot of people look at this method and say, yeah, no, that does not work for me. But what you need to do with that is you need to think about, really, that's the exact same thing as your, it's the exact same thing as your bridge map. Here's the only difference. The table is going up and down, so you're working up and down. The bridge map is the exact same thing, it's just going across. So when you look at this, notice we had the relationship between Ford and Chevy, just like we have here, Chevy and Ford. And that relationship was 6 to 2, just like up here. And we could have simplified that to a ratio of 3 to 1. We could have put that in the middle here. We could have said that 2 divided by 2 is 1, 6 divided by 2 is 3, and gotten that rate there, that unit rate. So 3 to 1, so that's 3 to 1, just like we have down here at the bottom. And then use that to get our ratio of 21 to 7. So times 7 here is 21, and times 7 on the bottom is 7. So really a ratio table is the same thing as using the bridge map. It's just one of them works up and down and one of them works across. Let's look at one last example. A punch recipe calls for only 2 ingredients. It needs 2 parts ginger ale and 3 parts orange juice. If the punch bowl has 8 cups of ginger ale, how many cups of punch are in the bowl? Now this problem is different than any of the others we've done so far. I'm wondering if you picked up on that. If not, read it again and see if you can figure it out. All right, now that you've read it again, if you notice, the ratio that we're given is 2 parts ginger ale and 3 parts orange juice. So though this is a part-to-part ratio, not because the word part is there, but just because ginger ale is part of our mix and orange juice is part of our mix. Then it says if the punch bowl has 8 cups of ginger ale, so that's part of the mix, how many cups of punch? Now, the punch is not a part of our mix, that's the whole mix, because it says a punch recipe calls for only 2 ingredients. So the punch is made up of both of the ingredients, the ginger ale and the orange juice. So the punch is a whole. So we're given a part-to-part ratio, but then we're asked to, if we're given one of those parts, what is the whole? So there's a couple ways we could do this. Most people start to set this up as a bridge map, and they say, well, I'm looking at the parts of ginger ale to the parts of orange juice. And it's 2 parts ginger ale to 3 parts orange juice. And then they go to put the 8 there. Well, it doesn't say we have, it does say we have 8 cups of ginger ale. But the problem is we're not looking for how many cups of orange juice. We're looking for how many cups of punch. So we cannot set this up that way. It won't work. What we do have to do is we do have to say, well, if I can I take this ratio and use it to write, so my question says if the punch bowl has 8 cups of ginger ale, how many cups of punch? So I need to take this and use it to write my ratio of ginger ale not to orange juice, but to total punch. And that ratio is going to be, see if you know what it is. Pause for a moment and think about it and see if you know it, and then play and see if you got it right. All right, what you should have gotten is a ratio of 2 to 5. That 5 is coming from the ginger ale and the orange juice are the 2 parts that make the whole, and the ratio of ginger ale to orange juice is 2 to 3. So those 2 parts, when you put them together, make a whole of 5. That's where the 5 came from. So I still have 2 parts ginger ale, but now that's 5 parts total because that's the ginger ale and the orange juice together. So now I could say, well, if I have 8 cups of ginger ale, how many cups of punch will I have? And 2 times 4 is 8. So then we need to do 5 times 4, which is going to give us 20 cups of punch. That's an easy enough way to do it as long as you recognize the whole part-to-part and part-to-whole thing and you're able to come up with the part-to-whole ratio. But you might do this whenever I see a problem like this, I think it's easier to do it using a tape diagram. So let's look at it and set one of those up. So our ratio of ginger ale to orange juice, GA is for ginger ale, OJ is for orange juice. That ratio is 2 parts ginger ale to 3 parts orange juice. What I know is the punch bowl has 8 cups of ginger ale. So if this part has to equal 8 cups, then each of these boxes has to be 4 cups. And if those 2 parts are each 4 cups, then the 3 parts of orange juice have to each also be 4 cups because the boxes all have to have the same value. And that gives me a total then of 12 cups of orange juice. Well, now how many cups of punch are in the bowl? It's going to be the 8 cups and the 12 cups together for a total of 20 cups of punch as my total. And I get that by adding the 8 cups and the 20 cups together. That should give you a good introduction to a variety of methods to be used for solving proportions. So when you are looking at a proportion word problem, keep in mind you can use bridge maps to show equal ratios or to find unit rates. You can use ratio tables. You can use double number lines. You can also use tape diagrams. choose the method that works the best for you for that particular problem. Whichever way is going to work for you. If you try one way and it just doesn't seem to fit and doesn't work for you, try a different way. So just keep trying until you can get it worked out.